Okay, first we're going to make or create a single view application. I'm just gonna go ahead and name it Tic Tac Toe, of course. Um, and if you can see my stellar special effects, it's my first time editing a video here with live video, so I just kind of winged it a little bit there. Yeah, so we're just gonna go ahead and create the application as normal. All right. Then we're going to create the layout. First thing we're going to do is going to create the layout. I just use labels and color them black for my grid, my 3x3 grid for the Tic Tac Toe board. I'm having a little issues here. Actually, I think I'm going to go to the preview. Yeah, that's what the preview, see what it looks like. Yeah, they were kicked into high gear because it's pretty boring, and I do struggle a little bit. I didn't want that to be too obvious, so I fast forwarded through there. All right. So once we get the board all set up, and again, it's just four labels, four intersecting labels, colored black, and then we just use buttons, regular buttons, fill up all that space. We have one label in the top right, that's going to be our status label, and another button in the top left, that's going to be our button to start a new game. And there we have it. Our Tic Tac Toe board is complete, and now what we can do is go ahead and start connecting our outlets. I want to start with the new game button in the top left. Go ahead and name it new game button. Nothing fancy. Give us a little room here. And then I'm going to speed it up a little bit. And I'm going to label the label in the upper right hand corner, status label, and then each button is just going to be button 1, 2, 3, 4, 5, 6, and so on. I actually threw some code in here a little early, so just ignore that for a quick moment. So after we connect all our outlets, we're going to create our actions. First is going to be the new game button clicked action, and make sure you select action instead of outlet. Go ahead and create that, and then we're going to create an action for each. Well, we're going to create one action and connect all of our buttons to that one action. I guess maybe I should have slowed that down a tad bit. Okay, so we have our actions and our outlets, and we're going to create. We're going to start with in the beginning of the game. And what happens at the beginning of the game? Anybody? All right, we're going to set it up so we're going to clear out all the tiles, remove any kind of X's or O's that are currently in them. We're going to reset our status label and get ready for a new game. So first, the player moves are going to be stored in an array called player moves, as you can see. Well, excuse me, a set called player moves, as you can see at the top. Some of the code that I entered previously. So what we're going to do is going to remove everything from the player 1 moves set and remove everything from the player 2 move set. And I labeled them. I set up as lets instead of bars, and since we're going to be changing them, there's code let me know that that should be bars instead of let. So you don't have to be perfect when dealing with Xcode, thankfully. All right, so we removed all the entries from our player 1 and 2 move sets, and we're going to reset our status label for the new game. I'm nervous, being this is my first video that I'm creating, but it looks like a little bit nervous typing there too. I've created this code already. I'm just going back over it, doing the voiceover. Alright, so after we reset our status label.text, we're also going to set our player turn variable to 1. So it's going to be player 1's turn at the new game. Player 1 goes first. Alright, then we're going to do a little for loop, a for in loop, and we're going to loop through 1 through 9, and we're going to, let me pause it right here. I wanted to pause it just so you can get a good look at this for loop and see what it's actually doing. What we're doing is we're going to loop through 1 through 9, and we're going to look in the view for any view that has a tag corresponding with that number that we're on in the loop. And if it does find one, we're going to set it as a UI button and then enable it and change the title. But I think I kind of fast forwarded through the setup of tags as we were setting our buttons up. So what I'm going to do is just kind of go back and throw that in there as a refresher. So just one moment. So what I did was took a screenshot and showed you where you would go to add tags to a button. Just click on the button, go over to the inspector, look down for the tag, add a tag. Start in the top left with 1 and in the bottom right with 9. And that's how we're going to keep track of our buttons within this program. So we cleared our player 1 move set, and we cleared our player 2 move set. We reset the status label. We set the player turn variable to 1, and we looped through all of our buttons and cleared them from any X's and O's that may have been there, and enabled them, because we will disable them on the winning game or a draw. So just a little heads up. All right. Then we call those functions in the new game button click action and in the view did load. So it's going to load to a new game, and then when you click the button, it's going to start a new game. All right. What is next? All right, that's the meat and potatoes. What do you do when you actually click on one of the tiles, the buttons? Okay, first we're going to check and make sure that it's never been clicked before. So we're going to check our sets and see if there's, see if that tag is located within those sets. And of course, again, the tag is how we're going to keep track of the buttons. When the button gets clicked, this function is going to receive a sender, which can be any object. It's going to be the button, and the sender is going to have a tag, and we're going to use that tag that we set to know which button was pressed, because they're all going to call the same action. All right, so if that button has been pressed before, what we could do is just disable it so it can't be pressed, or we can just let the user know, hey, that one's already been pressed, and that's what I just did there. All right. Otherwise, and here's where I was reading my old code and thinking, how can I kind of jazz it up a little bit while I do this. And then right here at the pause, like you can see, I'm kind of thinking in my head if I should do it or not. And I shouldn't have did it, but I did it anyway. Let me just pause it again here, just to tell you what's going on. All right, here I set the player turn. Well, I'm checking to see if the player turn variable is equal to 1. In this application, the player turn variable gets incremented by 1 each time a player takes a turn. So it's only going to be equal to 1 on that first turn. So I'm not sure why I thought I should do that, but I did it, and I'll see the error in my ways shortly. But but I just want to pause and let you know what if it is player one's turn. We're going to go on with the code insert. When I see my error, the sender tag, the button tag, into our player one moves set. All right, we're going to give the button a title, which is an X. It's going to show on the board, denoting that's our spot. And we're going to set the status label, letting the player know it's player two's turn. All right. And here's something else I should change. What I want to do is check and see if that last move is a winner, and we haven't created that function yet, so just bear with me a moment. But I should change the status label after we check if there's a winner, because if player one wins, and it's not going to be player two turn, so there's no point in telling them that. So, all right. And also, I tried to do something funny with this winner function. We'll see in a second. Okay, we're going to go ahead and create it. Just going to go right under our new game function. Is winner. And we're going to send it the player number, player 1 or 2. And it's just going to be integer. So the player hits. And we're going to kick out, trying to be fancy again, which it doesn't matter. We're going to return a bool, but I should be returning an integer. That's why I'm kind of going back and checking, because I'm looking at the code from the previous written application, and I'm saying, how can I make this work real quick? So I'm checking. And I believe this is where I see the error in my ways. Nope, still forging on. And we're going to declare a variable, a winner variable, and we're going to return that variable to return the winner if there is one. And we're also going to create a moves list, which is just going to hold any moves that have been already placed on the board. And we're going to check that moves list with winning combinations and see if there is a winner. And right here I just said if the player is equal to 1, we're going to use the player 1 moves. And if the player is equal to 2, of course, if it's anything other than 1, we're going to use the player 2 moves. And this is where I see the error in my ways. So I'm just going to go back and correct my code here in just one moment. So if you're typing along, just bear with me here. There we are. Yeah, so we're going to return the winner. I'm going to fix my spelling mistake here. Looks like I'm going to have to pause it here to explain that little chunk of code. Okay, I'll just pause it here while I'm looking for my error. Okay, so what I just copy and pasted was the check for a winning spot. What it does, it loops through winning combinations, the code that we placed at the top earlier, and it checks each combination. And if the move list contains each of the numbers in that winning combination, then we know we have a winner. So if you look, it says for combo in winning combination, So for each combination in winning combination, we're going to check if the move list contains combo subscript 0, which means the first object in that list there. So if it contains the first one and move list contains a combo subscript 1, which is the second one, and it contains combo subscript 2, which is the third one, the third object or number, then we have all the numbers in that winning combination. So it's a winner. And we also add a little check to make sure that the move list has more than two objects in there, just kind of a double check. So if the move list contains all spaces of one of those winning combinations, then we know that the winner equals the player that was sent through the check, the integer, player 1 or player 2. So we're going to change the status label to player 1 and player 2 has won the game. And then again, we're going to loop through the tiles and disable them instead of enabling them. All right, and since we set the winner variable to player, that's going to be player 1 or player 2, and it's not going to be true or false. So we need to kind of clean the code up a little bit here. Hold on, let's see how long it takes to kick in. Okay, here we go. So we're going to change our winner variable. We're going to initialize it with a 0. We're going to change bool to int, so we're going to return an int, and our winner variable is good to be returned. And we just got to go over here and change this a little bit. That player turn should be changed to 1 because we're checking for player 1 there, but we'll get to that later. Alright, so everything looks good so far. And don't forget to periodically check to make sure that your program is running properly. Give it a go. Alright. Now let's stop it right here. Alright, we stopped right here so I can explain what's going on. Okay, the last thing we did, we checked for a winner. So if is winner, it says player term, that should be 1 because we're checking for player 1. So if is winner equals 0, meaning there's no winner, that means it's computer's turn. So in that little if statement right there, we're going to enter the computer's defensive play, the computer AI. Alright, so we're just going to, instead of shoving all that code in there, of course we're going to make a separate function and call it from within that if statement. Alright, so okay, remember when I told you that the player turn is incremented by 1 every time a turn has been taken? Alright, so now I saw my error and I corrected it. So if you see inside the button clicked function, there is a if statement that says if player turn divided by 2 with the remainder is anything other than 0, which means it's an odd number, and it's player 1's turn. So, and okay, so now as you can see, now when we highlight that there, okay, that's what you're going to change. You're going to change it from player turn equals 1 to player turn module to anything other than 0. Okay. Alright. Set up to enter our defense. tidy things up a tad bit. All right. I'm going to create our play defense function. And what it's going to return is the space that we want the computer to occupy, or the computer wants to occupy. So it's going to return, it's going to let you know what it wants to do, the move it wants to make. So we're going to return it. There we go. More fumble fingers. Alright, so we're going to loop through the combinations just like we did to check for a winner. Except this time, what we're going to do, let me pull. Okay, the way we're going to find out if it's a winning or a losing situation for the computer or the human is we're going to utilize just a plain old counter. For each space that the human acquires, we're going to increment the counter by 1, and for each space that the computer has, we're going to decrement the counter by 1 also. And these spaces are referring to spaces within a winning combination. So we're going to check for we're going to go through each winning combination. So we're going to go through, we're going to look at spaces 1, 2, and 3. We're going to look at spaces 4, 5, and 6. We're going to look at spaces 7, 8, and 9. And then we're going to go down and diagonally. We're going to look at all those. Look at all those. So, excuse me. Again, for each space the human acquires, the counter will increment by 1. And for each space in the winning combination the computer has, the counter will decrement by 1. So if the human has 2 spaces out of a winning combination and the computer has none, the counter will read 2. If the human has 2 spaces out of the computer and the human has 2 spaces and the computer has 1, the counter will read 1 and we'll disregard it. We're only looking for 2 and -2, possible winning and possible losing situations. So let's do that. Okay, we're going to create our counter. Counter variable, count, we're going to set equal to 0. And then we're going to loop through our winning combinations. And we're going to look at each specific space in the winning combination. So for each play, I don't know why I named it play, but I did. For each play in combo, we're going to check and see if player 1 has that in their move list. And if we do, we're going to increment the counter. So if the human has it, we're going to increment by 1. So if they have an available space, if they can occupy a space in that winning combination, we're going to increment the counter by 1. And if player 2 has that space, has a space in the winning combination, we're going to decrement it by 1. Alright. So if the counter is 2, that means player 1 has a possibility of winning. We need to keep track of that somehow. So what we're going to do is we're going to create an array of possible losses, and it's going to hold the combination, the winning combination, or losing combination, whichever maybe. In this situation, losing. Alright. We're also going to create one to contain the winning combinations. So, if we're looking at 1, 2, and 3 on the board, spaces 1, 2, and 3, and the human has spaces 1 and 2, and the third space is available, then the count will be 2, and we're going to add that to our possible losses. This is from the computer's point of view, so possible losses. So the human has 2 spaces out of 3, and they might be able to win this, so we're going to add that to our list of possible losses. And then we're going to reset the count. I'm not sure why I did that. And then if the counter is equal to -2, that means the computer occupies 2 out of the 3 spaces needed to win, and it's a possible win for us, or excuse me, for the computer. And we'll add that to the possible wins. That combination. And again, I click the counter. Alright. Now, what do we do with those? Well, since this is the game I created, I want it to be a little bit more challenging than it has to be, really. So first I check for possible wins. If there's any win available to the computer, it goes for it. Alright, so for combo and possible wins, it's looking for the combination, and then it's going to compare the combination, the spaces in the combination, like 1, 2, and 3, to what it already has. I could have made this set ended that kind of easier, but I'm just thinking about that. So we go through the possible winning combination, for instance 1, 2, and 3, and we look at each space, and we compare each space to what we have in our moves list. So if space 1 and 2 are in our moves list, and we're checking both moves lists just to double check, just to be sure. So if player 1 contains the space, or player 2 contains the space, we do nothing. But if it does not, so that's why we do the exclamation point in there. If it does not contain the space, then we return that space, because that's our winning space. So if it's not in the list of spaces already, then we return it because that is the winning space we need. Alright. And again, well, not again. Here is where you can kind of set, if you want, you can set difficulty levels for your game. You can have it go straight for the win. You can have it kind of play defense and go protect against losses before it actually goes for the win. You can do all kinds of different things. And here we are, checking if there's any possible losses, and see if we have, seeing what space we need to block the human's win. So again, we check each space in the possible losing combination and see which one's available, and the one that is available we're going to add to our possible moves list, because sometimes there's more than one. But for the possible wins, we went straight for the win. Doesn't matter which way we win, as long as we win. So the first winning spot we see, we take it and we run. For the losses, we can kind of, hey, if there's more than one, we're in bad shape. So sometimes there are single spaces that are part of multiple combinations, so those single spaces can show up twice, and you can set your program to block against those as first priority. If you have more than 3 possible ways to lose. I'm not sure what game you're playing. Right, and there's we see we already declared our possible moves variables. So we just add that space to a list of possible moves. Alright, and sometimes, definitely at the beginning of the game, when you make a move, it's neither winning or losing matter. It's not life or death. So, um, it won't come up in the possible wins or possible losses categories. So, we're going to deal with that in a second. First, we're going to check and make sure that the possible moves list is empty. If it's not empty, we're going to return our next move. We're going to pick one at random. And here, again, you can change your difficulty level. You can be a little more strategic. Instead of picking a move at random from our next move. And we do need to next move. Why I did this out here, I don't know. But I did. We set it as a possible int, optional. And set to nil. And now we're going to say next move is equal to possible moves. We're going to subscript it, and we're going to pull one at random. No, we're going to explain how we get to it. Well, all we're going to do is take the total number of moves in the possible moves list. We're going to change that to a U32, and then we're going to pick one at random from that list, and that's that arc4 random underscore uniform. And then we're going to reconvert that to an int, and we're going to subscript our possible moves list and pick one. We're going to use that number as the index in our list, or array, excuse me, and return that as our next move. Here. And again, here is where we're going to say, hey, the game just started. It's not life or death. If there's no possible move losses or possible wins, what do I do? First, we're going to create a variable that lets us know what all our options are. So if we have no kind of help as far as a possible win or a possible loss, we need to know which direction to go. So we're going to say, hey, these are all your choices here. And those are all your choices, but some of those choices have been used already. So you need to figure out which ones have been used and kind of compare those to all the choices and see what's left. So, and here's again where I was trying to fancy the code a little bit while I was typing it up. And there's nothing wrong with it, but I just should have just typed it out as it was. Okay, so we're going to, these are sets, so what we're going to do is to find out which moves are less, we're going to take which moves are left, we're going to take all our moves, and we're just going to subtract the moves that are used. And the moves that are used are our player 1 moves, which I spelled wrong, and our player 2 moves. We're going to add our player 1 moves and our player 2 moves and subtract those from all our spaces. And what we have left is available spaces. We're just going to make sure there's actually spaces to go, moves to make. So that's why we say if the count is greater than 0, then we're going to randomly select one of those spaces and send it off, return it as our next move, just as we did from the possible move list, possible move array. And this is why I said I should just typed it out as it was, because I'm over here doing all kind of crazy stuff to get to the same. It was fine the way it was. Alright. And for a set, instead of just subscripting it, you gotta start at the beginning of the index and advance by your subscript number, which is our random number that we picked, just like the possible move list. Alright. Getting close to the end here. Okay. Then once all that's done, we're just going to increment the player turn and return the next move with an exclamation point, because we did say that was optional. Okay, and that's pretty much it for defensive play. It's actually pretty offensive minded also. There is one thing that I forgot here that's going to give me trouble when I try to run this program. Once you increment the player turn and return the next move, what I forgot to do is clear the list. I forgot to clear the possible moves and the possible wins and losses. So next time it comes around, the possible moves list is still going to have items in it, and so will the others. So, and that can cause issues. So I'm not sure why it's still. Oh, there we go. So, okay, now we're just going to go back to our if statement after we checked if player 1 is the winner, and if he hasn't won yet, if the human player hasn't won yet, we're going to enter our logic for the defense, computer's defense. And we're pretty much just going to declare another next move variable. Next move equal play defense. Parentheses. Oh, there we go. Try to kickstart it. It worked. Alright. And I must have been tired. I'm not sure what time. Okay, about 2 o'clock in the afternoon. I forgot something else here. I forgot to we forgot to add the next move to the player 2 move list. It's the computer's move list, which will cause issues also. So just keep that in mind for this moment. So just to describe what's going on, we cleared our variable next move, and we assign whichever move play defense presents for us. We assign that to the next move, and then we're going to take our button and we're going to assign the button with the tag that corresponds with our next move. We're going to give it an X, which should be no, because we use X for one thing. So I try to change a whole lot as I typed it, which is not good. At least I remember that. Instead of using the player turn, I put the 2 in there because we're checking for player 2. So is winner player 2? Oh, we don't know. And then we increment the player turn again. And if the player turn is greater than 9, because there's only 9 spaces, if it's greater than 9, it means we've used all our turn, nobody won. And we're just going to check to make sure the human player didn't win once more. You know, hometown favorites. So if it's the player turn is greater than 9 and there is no human winner, then it's going to be a draw. And we're going to loop through and disable all the buttons. Could have been a little dry with my button looping. Alright. Get that again. And there we go. Alright. Go ahead and run and check it out. But you will have some issues. Alright, now we're going to go fix them right now. And look at me, there I go, I found it. Add the 1 because we're checking for player 1 and not the player turn. Found my other mistake. We're going to add the computer's move to the playlist, the player 2 moves list, or move set. And then I find my other mistake, and we add the code to clear the player 2, the possible move. Alright. Possible move, and possible losses and possible wins. Boom. There we go, and that should do it. Now it should play for you flawlessly, and you better pay attention because. All right, so let's just play it a little bit. Just kind of randomly clicking spots just to make sure it's working as it should. See, it blocked my win there. I don't know what I'm studying here. It's a block now. I was like, okay, let me go for the win. All right. Where should I go? Anywhere, it doesn't matter. I really don't know what I was doing. Let's see if it can win. Not against me. Maybe against you. Thanks for joining me to create this Tic Tac Toe game. Hope you had a good time. I had one too. See you next video. Goodbye. You can download the project on GitHub. The link will be in the description. And check out my blog. The link is also in the description.